Welcome. In this first chapter, we will explore one of the most critical questions of our time: why sustainability? Sustainable development has become a central theme in global discussions about the future of humanity and our planet. It's a concept that connects politics, science, business, and civil society. But why now? Why has this idea become so urgent? To understand this, we must first acknowledge the incredible progress we've made. Compared to our grandparents' generation, we live in a world with greater connectivity, technology, and knowledge. In just the last 20 years, the proportion of people in extreme poverty has been halved. Global life expectancy has risen by 10 years since 1973, and global literacy has more than doubled since 1960. This remarkable progress, largely fueled by global economic growth, has improved living standards in countless ways. However, this development has come at a serious cost. We are navigating a new and challenging era in Earth's history called the Anthropocene. In the following sections, we will unpack what this means, examining the profound impacts of our growth, the limits of our planet, and a new framework for thinking about sustainable development in the 21st century. Let's begin by exploring the driving force behind this new reality. What you see on this slide are several graphs that tell a single, powerful story. This is the story of the Great Acceleration. Notice the shape of these curves for population, GDP, energy use, transportation, and tourism. They are relatively flat for centuries, and then, around the year 1950, they shoot upwards in an unprecedented dramatic spike. The human population alone has tripled since 1950. So, what enabled this explosion of human activity? In large part, it was made possible by the discovery and cheap availability of fossil fuels, especially oil. Oil became the engine of our economy, fueling industrial growth, global trade, and technological innovation. It allowed us to produce more food through fertilizers, build more infrastructure, and connect the world through travel. This miracle of development lifted millions out of poverty and created the modern world we know today. But this came with a hidden cost. In fueling our economy, oil and gas also ignited an insatiable hunger for all resources. This rapid exponential growth fundamentally reshaped our world, setting in motion a series of environmental consequences that we are only now beginning to fully comprehend. The Great Acceleration marks the moment when human activity became a truly global force. The next question, of course, is how did the Earth system react to this immense new pressure? As human activity accelerated, the Earth system began to respond. The graphs on this slide mirror the ones we just saw, but they track critical environmental indicators: atmospheric carbon dioxide, nitrous oxide, surface temperature, ocean acidification, and biodiversity loss. The pattern is strikingly similar and deeply concerning. Around the same time in 1950, these indicators also began a steep upward climb, moving far outside the range of natural variability. This data provides clear evidence that the surge in human activity is now the main driver of change in the Earth's life-supporting ecosystems. Our global economic system is destabilizing the very foundation that allowed human civilization to flourish in the first place, the Holocene. The Holocene was a remarkably stable climate phase that lasted for over 10,000 years, providing the predictable seasons and environmental conditions necessary for agriculture, cities, and complex societies to develop.
The changes we see here are so immense and so profound that scientists agree we have left the Holocene and entered the new geological epoch, the Anthropocene, or the Age of Man.
For the first time in our planet's history, humanity is the dominant force shaping its future. This realization has staggering implications for how we manage our relationship with the planet. This extraordinary growth has brought both progress and peril, which leads us to a crucial point of reflection. We've just discussed the Great Acceleration, a period that brought immense benefits in terms of wealth, health, and technology. But as we've also seen, it came with immense costs to our planet's life support systems. Now let's pause and reflect on a critical question of fairness and equity. Look at the scale. On one side, we have the engine of industry and economic growth. On the other, our planet. The question is, who has primarily enjoyed the benefits of this growth and who has borne the costs? Consider the global distribution of wealth and consumption. The benefits of cheap goods, air travel, and high resource lifestyles have been concentrated primarily in the world's rich countries. At the same time, the costs, such as pollution, resource depletion, extreme weather, and land degradation, are disproportionately borne by those in poorer countries. These are often the communities least responsible for the problem and least equipped to cope with the consequences. This unequal distribution of benefits and burdens is a central challenge in the pursuit of sustainable development. It reminds us that sustainability is not just an environmental issue, it is fundamentally a question of justice. To understand the risks we face in the Anthropocene, we need to grasp two key concepts: resilience and tipping points.
Resilience is the ability of a system, whether it's an ecosystem, a society, or an economy, to absorb disturbances and shocks without collapsing. Think of a grassland that can recover after being overgrazed.
However, every resilient system has its limits. If the pressure becomes too great or too widespread, the system can cross a threshold or a tipping point. Once a tipping point is breached, the system can rapidly shift into a new, often inhospitable state. Crucially, this shift is often irreversible. As the text notes, it's like trying to turn a loaf of bread back into flour. You can't simply undo the change. A tragic and powerful real world example is the Aral Sea in Central Asia, pictured here. Once the fourth largest inland lake in the world, it was a thriving ecosystem supporting a vibrant fishing industry. But in the 1960s, the rivers that fed it were diverted for irrigation projects. The lake began to shrink, its salinity skyrocketed, and its ecosystem collapsed. Today, what remains is a vast toxic salt desert, a testament to what happens when we push a system past its tipping point. The ROC is considered one of the greatest environmental disasters caused by humankind, and it serves as a stark warning of the irreversible consequences of exceeding planetary limits. Given the risk of crossing irreversible tipping points, a critical question arises: what can our planet bear? How much pressure can we put on Earth's systems before we risk widespread catastrophic change? To answer this, a team of leading scientists developed the Planetary Boundaries Framework. This concept identifies the 9 key Earth system processes that are central to our planet's stability and resilience. They are climate change, biosphere integrity, which includes biodiversity, stratospheric ozone depletion, ocean acidification, biogeochemical flows like the nitrogen and phosphorus cycles, land system change, freshwater use, atmospheric aerosol loading, and the introduction of novel entities like microplastics and chemical pollutants. Together, these 9 boundaries define what the scientists call a safe operating space for humanity. As long as we stay within these boundaries, we can expect the Earth systems to remain in a stable, Holocene like state, which is the state that has been so favorable for human civilization. Moving within this space means the risk of dangerous, irreversible environmental change is relatively small. However, if we exceed these boundaries, we push our planet toward unknown tipping points and endanger the stability of the entire Earth system and thus the basis of our own existence. This framework gives us a scientific guide for navigating the challenges of the Anthropocene. So, how are we doing? This diagram serves as humanity's report card, and the results are alarming. The green area in the center represents the safe operating space. The red areas show where we have already transgressed the planetary boundaries, pushing us into a zone of high risk. According to the latest scientific analysis, we have already exceeded the safe operating space for 5 of the 9 boundaries. These are climate change driven by our greenhouse gas emissions, biosphere integrity, evidenced by an extinction rate far above the natural background level, land system change, primarily through deforestation for agriculture, novel entities, which includes the pervasive pollution from plastics and chemicals, and finally, biogeochemical flows, where our use of nitrogen and phosphorus fertilizers has radically disrupted natural cycles. A critically important note here is that these 9 boundaries are not independent silos. They are highly interconnected. Stress on one can push another further over its limit. For example, climate change exacerbates biodiversity loss, and deforestation, a form of land system change, in turn worsens climate change by reducing the planet's ability to absorb CO2. This interconnectedness means we cannot solve these problems one by one. We need a holistic approach that recognizes the Earth as a single, complex, integrated system. This report card is a clear and urgent call to action. The planetary boundaries framework gives us a global snapshot, but it's crucial to understand that the consequences of exceeding these limits are not distributed equally across the planet. A global average can hide severe regional crises. These maps illustrate this point perfectly. They show the status of 4 key boundaries at the regional level: the phosphorus cycle, the nitrogen cycle, land system change, and freshwater use. The green areas are within the safe boundary. Yellow indicates increasing risk, and red signifies a high-risk zone, well beyond the boundary. As you can see, the pressure is not uniform. For instance, the stress on the nitrogen and phosphorus cycles is most intense in agricultural heartlands like North America, Europe, and parts of Asia. Freshwater use is a critical issue in the Middle East, North Africa, and parts of India and the United States. This means that while the concept is global, the impacts are deeply local. Rising sea levels caused by climate change are an existential threat to people living on small islands and in coastal areas, while the consequences might be felt primarily as economic costs in a landlocked country like Switzerland. This localization of impacts is essential to remember, as it connects these vast, abstract concepts to the real-world experiences of communities everywhere. It's also important to note the gray areas on these maps, which represent regions where reliable data is not yet available, suggesting the situation could be even more challenging than we currently know. We've just established that while the planetary boundaries are a global concept, their effects are felt locally. Now, let's take a moment to make this personal. Think about the community where you live. Which of these environmental pressures are most visible in your community? Think about issues like access to water. Do you experience droughts or restrictions on water use? What about pollution? Are there concerns about air quality from traffic and industry? These global challenges manifest in our daily lives in very tangible ways. Taking a moment to connect these large scale scientific concepts to your own local environment can make them much more real and understandable. By identifying the pressures in our own backyards, we can better appreciate the urgency of finding solutions that work not just on a global scale, but in the places we call home. We've explored the ecological limits of our planet, but what about the needs of its people? Sustainable development must address both. This brings us to a powerful new framework created by Oxford economist Kate Raworth, donut economics. Frustrated that traditional economic theories were disconnected from real world social and ecological crises, she sought to create a new model. As she put it, she tried to draw a picture of humanity's goals and it came out looking like a donut. This model provides a visual guide for sustainable development. The outer ring is the ecological ceiling, composed of the 9 planetary boundaries we've just discussed. This is the environmental limit that we must not overshoot to avoid degrading our planet's life support systems. The inner ring represents the social foundation. This consists of 12 minimum social standards that no one should fall below. These are derived from the UN Sustainable Development Goals and include essentials like food, water, education, income and work, peace and justice, and equality. Between these two rings lies the goal, the green space. This is an environmentally safe and socially just space for humanity, where everyone's needs can be met without compromising the health of the planet. The donut gives us a new compass for progress, shifting the focus from endless GDP growth to thriving in balance. So, where does humanity currently stand in relation to the donut? This image paints a clear and challenging picture. Despite all the progress we've made, we are failing on both fronts. We are simultaneously falling short on the social foundation while overshooting the ecological ceiling. Let's look at the inside of the donut first, the social shortfall. The red wedges show the proportion of people worldwide who lack life's essentials. As the data highlights, approximately 820 million people, or 11% of the global population, are undernourished. Unsafe water is responsible for 1.2 million deaths each year, and 1 in 6 children between the ages of 12 and 15 is not in school, the vast majority of them girls. Millions of people are still being left behind. At the same time, we are collectively breaking through the planet's boundaries on the outside. The diagram highlights 4 critical boundaries that have been crossed: climate change, excessive nitrogen and phosphorus loading from agriculture, land conversion, and devastating biodiversity loss. We are living outside the donut on both sides, creating a dual challenge. The fundamental task for the 21st century is to find a way to meet the needs of all people within the means of our living planet. This brings us to the fundamental question at the heart of the sustainability challenge. Historically, economic growth has been the engine of both our social progress and our ecological problems. To live within the donut we have to break this link. This leaves us with two primary options. The first option is to decouple. This means radically separating economic growth, measured by GDP, from resource consumption and environmental impact. The goal would be to continue growing our economies while dramatically reducing our ecological footprint through new technologies and massive gains in efficiency. The second option is to rethink growth. This approach, often called post-growth, suggests that in wealthy nations, the pursuit of constant economic growth is the problem itself. It proposes slowing down or ending the pursuit of growth and focusing our economic goals on social well-being, ecological regeneration, and justice instead of simply growing GDP. So how we achieve decoupling? The chart on this slide shows domestic material consumption per unit of GDP. While some countries like China and Switzerland have improved their material productivity, the global average, which is the dark blue line, has remained almost constant for the last 2 decades. This tells us we have not yet achieved a global decoupling. This immense challenge is leading to new economic models like the circular economy, which focuses on efficiency and reuse, and the post-growth economy, which focuses on well-being. Ultimately, some may see the choice as being between protecting the environment and growing the economy, but this is a false dichotomy. The key idea to take away from this module is that ecological instability and climate change pose a direct and massive threat to global GDP and economic prosperity. Sustainability is not a cost, it is an economic imperative. The data speaks for itself. A report from Swiss Re projects the potential loss in global GDP by 2050 compared to a world without climate change. If we do nothing and temperatures rise by 3.2 degrees Celsius, we face an 18% loss in global GDP. On our current trajectory, that loss is projected to be between 11% and 14%. Even if we meet the Paris Agreement goals, we still face a 4% economic loss. Inaction is clearly the most expensive option. Furthermore, these costs are not shared equally. Data from the United States shows that climate change will cost the economy roughly 1.2% of GDP for every 1 degree Celsius of warming, with the poorest countries projected to suffer damages between 2 and 20% of their income. Climate change will dramatically increase economic inequality. Therefore, the message is clear. Investing in a safe and just future is not a burden on the economy. It is an investment in a stable, prosperous, and equitable economy for all. This is why sustainability is no longer a niche issue. It is the central economic challenge of our time.